Hello everyone, I am Saimani Gopal Reddy and I have with me Venkadaditya Kantipudi. So we are here to talk about a research paper called Matches, Mismatches and Methods, Multiple View Workflows for Energy Portfolio Analysis. In this study, the author worked to develop visualization techniques that help with analyzing the energy data for large building portfolios efficiently. Let's dive into how these visualizations can support better energy management. I would like to ask Venkadaditya to take over the presentation.
Coming to background of this research paper, we're dealing with analyzing energy performance across multiple buildings is a really challenging task. In this research, mainly focus on improve how to improve and analyze and monitor the energy usage of large group of buildings like university campus or large company portfolios. Current tools struggle because they either can't handle a large amount of data or they simplify the data too much. So in collaboration with NRNOC, they have their own tool called Energy Manager, which aims to improve the existing tool by creating visualizations. The objective of this research paper was to develop visualizations that can handle larger building portfolios and support various analytical tasks. Coming to these research questions we have solved in this research paper was what type of visualizations work best for analyzing energy data and how can these visuals be integrated into workflows and how can visualizations be designed to build familiarity with trust among users, especially those who are not advanced with visualization techniques. Now I let Simon Gobal ready to continue.
So coming to methodology, uh, the researchers have conducted interviews with nine energy workers to understand their needs and challenges. They understood that their employees have different role skills and several years of experiences differences. So based on this, they have categorized data into different abstractions, which we have as data and task abstractions, which are used to analyze data and tasks to develop proper visualizations. Once these visualizations are developed, they will be put in a prototyping environment called sandbox. Once these visualizations are placed in this sandbox, they will be presented to the collaborators and energy workers, where feedback will be collected from them and their feedback will be reiterated into the prototyping environment. And coming to the tools that are used in developing the prototype environment are Shiny and D3.js, which are used for creating interactive visualizations. Uh, if we dive deep into data and task abstractions, after work domain analysis, they have developed uh, developed to develop visualizations. They categorize data into these different abstractions. Data abstraction is used to simplify the complex data, while task abstraction is divided into three types: overview, drill down, and roll up. Overview is for overall visualizations of the energy consumption or energy demand for the for all the buildings. Drill down is if you want to compare two or three buildings or multiple buildings side by side. For roll up is if you want to see how much composition a particular building has energy consumed for a particular building of over all the buildings energy consumed. And for coming to task sequence, it is how the users interact with the system, whether they start with the overview or whether they start with the drill down or roll up. It all depends on the user and how they want, what information they want to visualize. Here in the table, you can see the data abstraction that we have discussed. It contains building metadata, temporal data, and derived data. Coming to how the existing tool this is how the existing tool is. The existing tool Energy Manager had several shortcomings. It wasn't scalable, it didn't support detailed filtering or aggregations, and users often had to export data to Excel for deeper analysis. This showed that tool wasn't meeting the analytical needs of energy workers, prompting for a better solution, which our authors have developed. When we see this line graph, this is a continuous line chart used for aggregated data. It sometimes leads to misconceptions, and it doesn't have the roll up task where we can understand the composition of a particular building's energy consumption or demand when compared to all other buildings. And if you see in the figure A, they have showed a table, but they only showed relative ranks. Users doesn't find it interesting, and they avoid the overview because it doesn't really show them anything. So if you want to compare some buildings performance, it would better be they would better be using a bar chart for this purpose. In this, the shortcomings of the existing tool is that it doesn't support sequence tasks sequentially. That means users there is no smooth transition from overview to drill down, or from drill down to roll up, and it lacks visualization which are linked. Like for example, when you click on a bar, it should also filter out the data for the remaining visualizations. It is not happening here. And also there is a limited support for filtering and aggregation. Thus, many energy workers have to export the data and use Excel for analysis purpose. Prototyping environments will be discussed by Venkataditya.
When coming to prototyping environments of this research project, we have developed aggregation, unit selection, and normalization of data, and have made some filters for selecting the required electricity type, like it's natural gas or electricity or solar, and we have some sorting order, and we can have ascending or descending in the results, and we can filter with the geographical locations, and we can have all these type of filters where we can get the top five and bottom five of the selected filters, and we can get interaction with data by users could interact with variations to highlight data, drill down, or compare across buildings. Various techniques were tested in prototype to evaluate their effectiveness. When coming to proposed visualization techniques, for overview type of tasks, we prefer juxtaposed matrix and box plots, and for drill down, faceted bar charts and faceted line graph, and for roll up, stacked area graph and stacked bar chart are preferred in these type of tasks. For faceted bar charts, it shows the bar charts side by side, and it was so effective for drill down tasks and not scalable for large data sets. But in faceted line charts, it shows individual line chart for each time series, and it was good for drill down tasks. And in faceted box plots, it displays distributions and extreme values for multiple time series. It was found ineffective for drill down tasks. And if you see bump plots, it shows rank changes over time. So it was not effective for overview type of tasks. To overcome this, we have combined bar plot with bump charts so that we can have both rank and absolute value of the particular building or any type of energy performance value. It was possible match for overview tasks. And while seeing calendar matrix, it shows it is a variant of time series matrix, and it shows day by day and month by month and year by year for various years for a particular building. When we go to map-based evaluations, it shows data on geographic map. For a particular area, we can have the data with colors plotted. It was inappropriate for energy analysis due to lack of context, and in stack data charts, it shows cumulative energy, and it was effective for roll-up tasks. Yeah, I will. In stacked bar charts, it shows aggregated values, and it was so ideal for roll-up tasks. I will let Simon Gopal ready to continue.
So when it comes to workflow design with multiple views, till now we have discussed how single views would look like. But in reality, they would want to use multiple views like here juxtaposed matrix and box plots. When you click on one of the on any area of the matrix plot, it would also change the values for the box plot. And the box plot highlights the outliers and distribution of the energy data, which is very useful for the energy workers. And when it comes to juxtaposed, stacked, and faceted charts, here we can do two tasks at a time, which is drill down and roll up tasks. So drill down tasks can be done in the stacked area chart, where they can drill down task can be done in the below chart, which is faceted charts, where they can analyze the performance of multiple buildings, and a stacked area chart is used for the roll-up tasks. Uh, and coming to the redesign in Energy Manager, after all these thoughts and visualization techniques, they have incorporated multiple views into the energy manager, and finally have created this visualizations you can see on the screen. The redesigned tool integrated multiple views that work together to support different stages of analysis. For example, you can start by looking at the matrix for the bigger picture, then drill down into individual buildings using faceted line charts, and finally roll up to see the cumulative values using stacked area charts and stacked bar charts. The tool also includes interactive features like linked brushing, filtering, which help users maintain context while exploring data, which is missing in the existing tool. Evaluation and results will be discussed by Venkataditya.
Yeah, in evaluation of results of this research paper, we can have new designs, including matrix views, faceted charts, and stacked charts, which were incorporated in Energy Manager tool. And it has an fuse impact on user experience as it improves usability and interactive capabilities, which increases in client base and which give positive feedback from stakeholders too. Contributions made from data visualizations saw the other focus mainly on which type of visualizations work well and which doesn't work well for different types of tasks in energy management performance, and guidelines for design verification where they created general guidelines to help others design effective visualizations, focusing on concepts of familiarity and trust. In effectiveness of visualization designs, faceted line and bar charts are effective for drill down, and matrix-based views are efficient for space multiple time series at once, and it was effective for overview tasks. Stake data and bar charts were effective for roll-up tasks. When it comes to weaknesses, faceted line and bar charts are becomes more cluttered with too many categories. If there were too many buildings, then it would be cluttered. For matrix-based views, it was difficult to review for a new user as it interrupts without any additional guidance. Stacked area and bar charts are difficult to distinguish between individual components in detailed datasets.
So coming to suggested improvements, there are a few improvements that I would like to suggest here. First thing would be use simpler visualizations for new users like bar charts, and let users switch between simple and detailed views by enabling a toggle or disabling a toggle. And one thing would be to add tutorials, like user guided tutorials when they first visit the uh, tool, so that it will be helpful and they would not need the help of existing employees or old employees. And they can also provide options for the users to explore visualizations based on their preferences, and also implement breadcrumbs navigations so that they would know how they have come to a particular area, or where they wanted to go next. Coming to the conclusion, in conclusion, this study developed new visualizations that effectively support energy analysis for large building portfolios. While redesigning was a big improvement, there is still room to simplify the tool and make it more accessible for all users. In future, the focus should be on balancing complexity and usability and adding more user-friendly features. Thank you for listening. I'm happy to answer any questions or hear your thoughts on the research and the proposed visualizations on the discussion board. Thank you. Have a great day.